Welcome back to my channel. In the last video, we have discussed the exercises from the section 1.2 of the textbook Calculus and Analytic Geometry by Thomas and Finney. We discussed exercise 1 to 30. Today we are going to discuss the remaining exercises. The next question is, suppose limit extend to 0 f of x is equal to 1 and limit extend to 0 g of x is equal to minus 5. Name the rules in theorem 1 that are used to accomplish steps A, B and C of the following calculation. A calculation is given here. We have to say which are the rules used in each steps. The rules is properties of limits. We already discussed in last video what are the properties of limits. We have discussed 6 properties. First one sum rule, difference rule, second one, third one product rule, fourth one constant multiple rule, fifth one quotient rule and sixth one power rule. Sum rule is limit of the sum of function is sum of the limits. Similarly difference rule is limits of the differences, difference of the limit, and similarly product rule, constant multiple rule, etc. Here the calculation is limit extend to 0 2 into f of x minus g of x by f of x plus 7 the whole power 2 by 3. Look to the next first step, step A. Limit extend to 0 2 into f of x minus g of x divided by limit extend to 0 f of x plus 7 the whole power 2 by 3. Clearly it is quotient rule. Limit of the quotient of function is quotient of the limit. Step A is quotient rule. Step B, look to the step B. Here limit extend to 0 2 into f of x minus limit extend to 0 g of x. In the numerator we applied this difference rule, and in the denominator limit extend to 0 f of x plus 7 the whole power 2 by 3. Here limit of the power, here power of the limit. So here we used power rule. And in the third step, here in step B, in the numerator we used difference rule, and in the denominator we used power rule. In step C, limit extend to 0 2 into f of x is written as 2 into limit extend to 0 f of x, that is constant multiple rule, minus limit extend to 0 g of x by, here again in the denominator limit extend to 0 f of x plus 7 is written as limit extend to 0 f of x plus limit extend to 0 7, that is sum rule, the whole power 2 by 3. Here in the numerator we used constant multiple rule, and in the denominator we used sum rule. Next step, in the question already given limit extend to 0 f of x is equal to 1 and limit extend to 0 g of x is equal to minus 5. So last substitution. Instead of limit extend to 0 f of x, substitute 1, and instead of limit extend to 0 g of x, substitute minus 5. We get 2 into 1 minus 5 by 1 plus 7 whole raised to 2 by 3 equal to 7 by 1. 1 plus 7 whole power 2 by 3 is 8 power 2 by 3. 8 power 1 by 3 is just a cube root of 8, which is 2. 2 raised to 2 is 4. So 7 by 4. And therefore the answer is A, quotient rule, B, difference rule and power rule, C, constant multiple rule and sum rule. Next question. Suppose a limit extend to C f of x is equal to 5 and limit extend to C g of x is equal to minus 2. Find A, limit extend to C f of x into g of x, B, limit extend to C 2 into f of x into g of x, C, limit extend to C f of x plus 3g of x, D, limit extend to C f of x by f of x minus g of x. A, limit extend to C f of x into g of x. We have limit extend to C f of x into g of x is limit extend to C f of x into limit extend to C g of x. Product rule. Product rule. Now limit extend to C f of x is equal to given 5 and limit extend to C g of x is equal to minus 2. Therefore the answer is minus 10. B, limit extend to C 2 into f of x into g of x. just apply product rule and constant multiple rule. Product rule, limit x tend to c 2 into f of x into limit x tend to c g of x. Next step, apply constant multiple rule. 2 into limit x tend to c f of x into limit x tend to c g of x. Then substitute, limit x tend to c f of x is equal to 5 and limit x tend to c g of x is equal to minus 2. Therefore 2 into 5 into minus 2 is equal to minus 20. C, limit x tend to c f of x plus 3g of x. First apply sum rule. Limit x tend to c f of x plus limit x tend to c 3 into g of x is equal to limit x tend to c f of x plus, here apply constant multiple rule, 3 into limit x tend to c g of x. Now limit x tend to c f of x is 5 plus 3 into limit x tend to c g of x is equal to minus 2, equal to 5 minus 6 is equal to minus 1. D, limit x tend to c f of x by f of x minus g of x. First apply quotient rule. Limit x tend to c f of x by limit x tend to c f of x minus g of x. Then apply difference rule in the denominator. Become limit x tend to c f of x by limit x tend to c f of x minus limit x tend to c g of x. Substitute, limit x tend to c f of x is equal to 5 and limit x tend to c g of x is equal to minus 2. 5 minus minus 2 equal to 5 by 7. Next question. Suppose limit x tend to be f of x is equal to 7 and limit x tend to be g of x is equal to minus 3. Find A, limit x tend to be f of x plus g of x, B, limit x tend to be f of x into g of x, C, limit x tend to be 4 into g of x, D, limit x tend to be f of x by g of x. A, limit x tend to be f of x plus g of x equal to sum rule. Limit x tend to be f of x plus limit x tend to be g of x. Limit x tend to be f of x is given 7 and limit x tend to be g of x is equal to minus 3. Therefore 7 plus minus 3 equal to 4. B, limit x tend to be f of x into g of x. Product rule. Limit x tend to be f of x into limit x tend to be g of x equal to 7 into minus 3 is equal to minus 21. C, limit x tend to be 4 into g of x. Constant multiple rule. 4 into limit x tend to be g of x equal to 4 into limit x tend to be g of x is minus 3 is equal to minus 12. D, limit x tend to be f of x by g of x. Quotient rule. Limit x tend to be f of x by limit x tend to be g of x. F of x is 7 and limit x tend to be f of x is 7 and limit x tend to be g of x is minus 3. Therefore minus 7 by 3. Next question. Limit of average rates of change. In exercise 37 to 42, evaluate the limit h tends to 0 f of x plus h minus f of x by h for the given value of x and a function f. We have to find limit h tend to 0 f of x plus h minus f of x by h. This limit is called the limit of average rates of change. And next questions, we have to find this limit. You can look to the question. 37, f of x is equal to x square, x is equal to 1. We have to evaluate limit h tend to 0 f of x plus h minus f of x by h at x is equal to 1 for this function. Given f of x is equal to x square. Therefore f of x plus h is equal to x plus h the whole square. Now we have to find this limit. limit h tend to 0, f of x plus h minus f of x by h is equal to f of x plus h is x plus h the whole square. Limit h tend to 0, x plus h the whole square minus f of x is x square by h equal to limit h tend to 0, x plus h the whole square is x square plus 2xh plus h square minus x square by h. X square minus x square is 0. Becomes a limit h tend to 0, 2xh plus h square by h equal to limit h tend to 0. Here h is common, h into 2x plus h by h. H get cancelled, become limit h tend to 0, 2x plus h. Limit h tend to 0, 2x plus h is 2x. At x is equal to 1, this becomes 2x is equal to 2. At x is equal to 1, limit h tend to 0, f of x plus h minus f of x by h is equal to 2. This is the answer. Next question, f of x is equal to 3x minus 4 at x is equal to 2. F of x is equal to 3x minus 4. Therefore, f of x plus h is equal to 3 into x plus h minus 4. We have to find limit h tend to 0, f of x plus h minus f of x by h equal to limit h tend to 0, f of x plus h is 3 into x plus h minus 4. 3 into x plus h minus 4 minus f of x is 3x minus 4. 3x minus 4 by h is equal to limit h tend to 0. Expand this. This is 3x plus 3h minus 4 minus 3x plus 4 by h. 3x minus 3x is 0, minus 4 plus 4 is 0. Remaining is limit h tend to 0, 3h by h. H get cancelled. Therefore, limit h tend to 0, 3 equal to 3. Limit of a constant is always the constant. Therefore, at x is equal to value, at x is equal to 2, the value is same. At x is equal to 2, limit h tend to 0, f of x plus h minus f of x by h is equal to 3 itself. Next question, f of x is equal to root x at x is equal to 7. F of x is equal to root x. Therefore, f of x plus h is equal to root of x plus h. Therefore, limit h tend to 0, f of x plus h minus f of x by h becomes limit h tend to 0, root x plus h minus root x by h. Here, limit of the denominator is 0. So, we have to multiply by the conjugate. Here is an irrational function, so we can multiply it by the conjugate. Multiplying and dividing by the conjugate. The conjugate of root x plus h minus root x is root x plus h plus root x. We get limit h tend to 0, root x plus h minus root x by h into root x plus h plus root x by root x plus h plus root x. This becomes limit h tend to 0, a minus b into a plus b, a square minus b square. Become x plus h minus x. Root x plus h the square is x plus h and root x square is x by h into root x plus h plus root x. Now we eliminated the zero denominator. Here x minus x is 0, h by h gets cancelled. Limit h tend to 0, 1 by root x plus h plus root x. So we eliminated the zero denominator. Then it becomes 1 by limit h tend to 0, root x plus h is root x. Root x plus root x 2 root x Therefore, at x is equal to 7, this becomes 1 by 2 root 7. By 2 root 7. To solve the next question, we need the sandwich theorem. Suppose that g of x less than or equal to f of x less than or equal to h of x for all x in some open interval containing c except possibly at x is equal to c itself. Suppose also that limit x tend to c g of x is equal to limit x tend to c h of x is equal to L, then limit x tend to c f of x is equal to L. The concept of sandwich theorem is very simple. If we have three functions satisfying the condition g of x less than or equal to f of x less than or equal to h of x, and also limit x tend to c g of x is equal to limit x tend to c h of x, then limit x tend to c f of x is equal to L. Suppose f, g and h are three functions satisfying g of x less than or equal to f of x less than or equal to h of x, and limit of g of x and limit of h of x are equal, then theorem says limit of f of x is also equal to the same value. Next question is, if root 5 minus 2x square less than or equal to f of x less than or equal to root 5 minus x square, 4 minus 1 less than or equal to x less than or equal to 1, find limit x into 0 f of x. We have three functions with satisfying the conditions in sandwich theorem. We have to check whether the limit of root 5 minus 2x square and limit of root 5 minus x square is equal. Then the limit x tend to 0 f of x will be equal to that value. So we can check limit x tend to 0 root 5 minus 2x square is equal to this substitution. We get a root 5, and limit x tend to 0 root 5 minus x square is also equal to, by substitution we get root 5. That is limit x tend to, limit of these two functions are same. Limit x tend to 0 root 5 minus 2x square equal to limit x tend to 0 root 5 minus x square equal to root 5. Therefore, by sandwich theorem, limit x tend to 0 f of x is equal to root 5. By sandwich theorem, limit x tend to 0 f of x is equal to root 5. Next question. It can be shown that the inequalities 1 minus x square by 6 less than x sin x by 2 minus 2 cos x less than 1 hold for all values of x close to 0. What, if anything, does this tell you about limit x tend to 0 x sin x by 2 minus 2 cos x? Give reason for your answer. Here the first condition in sandwich theorem is already given. Now to tell something about the limit of the function in the middle, that is a limit x tend to 0 x sin x by 2 minus 2 cos x, we have to check whether limit x tend to 0 1 minus x square by 6 and limit x tend to 0 1 are same. Here limit x tend to 0 1 minus x square by 6 is, this substituting we get 1, and also limit x tend to 0 1 is equal to 1, since limit of a constant function is always the constant. Therefore we get this second condition of the sandwich theorem. Limit x tend to 0 1 minus x square by 6 is equal to limit x tend to 0 1 equal to 1. Therefore by sandwich theorem, we get limit x tend to 0 x sin x by 2 minus 2 cos x is equal to 1. Next question. If limit x tend to 4, f of x minus 5 by x minus 2 equal to 1, find limit x tend to 4, f of x. Here given limit x tend to 4, f of x minus 5 by x minus 2 is equal to 1. We can expand this limit. Limit x tend to 4, f of x minus 5 by x minus 2 is, just applying quotient rule, we get limit x tend to 4, f of x minus 5 by limit x tend to 4, x minus 2. Again applying difference rule, in the numerator we get limit x tend to 4, f of x minus limit x tend to 4, 5. It is limit of a constant is always the constant, therefore we get 5 by limit x tend to 4, limit x tend to 4, x minus 2 is 4 minus 2, which is equal to 2. That is, we get limit x tend to 4, f of x minus 5 by 2 is equal to 1. From this we get limit x tend to 4, f of x equal to 2 plus 5 is equal to 7.